Hi guys, I want to show you how to do the data analysis with Excel programs. Okay, let's say we have this data from our experiment, effects of salinizations on seed germinations. So there are 5 different treatments. Control 0 part per 1,000 salt. Okay, and then second one is 5 ppt, 10 ppt salt concentrations, 20 ppt, and 40 ppt. And there are 3 replications for this experiment. And these are the data that we have from that experiment. So we want to know whether this treatment has any difference or not. In order to do that, we're going to perform the data analysis using Anova, analysis of variance. So to do that, make sure you have the Anova in your Excel. You can check, or if you don't have it, just try to click this file and then click option. And over here, click add in. Okay. Over here, you see the Excel adds in. Just click go. And then make sure here on the box, it's an analysis tool pack. Make sure it is checked. If it is checked, if it is not checked yet, you have to check it and then click OK. Now you should have the Anova analysis in your Excel. Now to do the Anova, the data analysis, then click data, okay, and then click data analysis here on the right side, okay, and then look for Anova single factor, click that, and then click OK. Now we have to put the data, which is the input range. It's going to be this one in the middle. Okay, so this all the data actually. Okay, so this is our data, which is 3 replication with 5 different treatment. And then make sure you click column because we're gonna calculate this based on the column. So every column is actually different treatment. And then you already have this alpha 0.05. And then you can put these results, whether in the new workbook or maybe new worksheet, okay, or maybe output range. I like to put in the output range so I can see this result right away in this Excel, in this screen. See, so I click that one and then you have to put where you're gonna put that results. So I'm gonna put here, so make an output range over here and then click OK. Okay, now you see that we have the results over here. Okay, I want to make it wider. Okay, so the columns make it wider, let's say 12. Okay, now you see the result over here. Okay, now over here it say that column 1, column 2, 3, 4, and 5. This one is actually treatment. So to make sure we do understand what it is, we can change it. Okay, so column 1 will be 0 part per 1,000 salt, which is control. Column 2 will be 5 ppt. Column 3 is 10 ppt. Column 5 is 20 ppt. And last one is 40 part per 1,000 salt concentration. Okay, so just for your information, the ocean water, the seawater usually have about 32 to 35 ppt. Okay, it means that our treatment over here is over the salt concentrations of the ocean water. Okay, so this is very high concentration. This is very salty solution. Okay, now the one that is important for you is actually looking for this value over here, the P value. Remember, the alpha value is 0.05. It means that if the P value higher than 0.05, we have to accept the null hypothesis, which is there is no difference within the treatment. But if the P value is lower than 0.05, it means that we have to reject the null hypothesis. It means that there is difference between this treatment. So if you see over here, the phi value, I'm going to make it bold over here. It's actually 0.0000299. There are 90 over here. It means that it's lower than 0.05. So to make sure we do understand, we actually can put, like, say, conclusion over here for this result. Okay, because of the P value is lower than 0.05, then we have to reject. What? We reject the null hypothesis. Okay, it also means that there is, okay, so there is difference between the treatments. Okay, so we know based on this Anova result, there is difference between this treatment. Control 5, 10, 20, and 40. However, we don't really know which one is actually different, whether control and 5 different, 5 and 10 is it different, or 10, 20 is it different, control and 10 is it different. Okay, so we have to do the next test. It's called the Tukey test in order to know which treatment is actually different. Okay, so which treatment different with what treatment. So in order to do this Tukey test, there is a website that can help you. I'm gonna pull this website over here. Okay, so this website is a Tukey test. Okay, which is it will test whether which treatment is different with what treatment. So we see that we have five, right? We have 5 treatment. Then we have to click. We have to check K equal 5. So this is 5 treatment: 0, 5, 10, 20, and 40 part per thousand salt concentration. After we click this K equal 5, then we click proceed to enter your treatment data. So click this, okay, and then click this out. Okay, click that. I think we have to go back here. We will not use K equal 4 because our K is actually 5. Okay, let's go back and make sure we put K equal 5, and then, okay, there is a checkbox over here. Check this box. You wish to use the demo example, which is K equal 4. We will not use K equal 4 because our treatment, our sample is actually have 5 different treatments. So we're gonna uncheck this box. Okay. And then we proceed to our data. Now you have 5 different treatment. Okay, sample number 1. Okay, we have to look our data over here. Okay, it say 10, 10, 9. So number 1 is 10, 10, 9, 10, 10, and then 9. Okay, and then the second group, which is the 5 PPT, is 9, 10, 9. In 10, 9. Okay, and then the next group is 9, 8, 8. 9, 8, 8. Okay, the next group, the 20 PPT is 8, 7, 7. 8, 7, 7. Okay, and the last one, the 40 PPT, there were no seed germinate, all 0, 0, 0, 0. It means that this salt concentration actually kill the seed. So the seed did not germinate. Okay, after we put this data in this table, then click calculate Anova with Tukey tests. Okay, the one that you really need is actually in this table over here. So the result. So we can highlight this, highlight it. Okay, and then right click to copy. We're gonna put it in our Excel. So you're gonna see the result actually here. We're gonna put here. So make sure when you paste this, choose the destination formatting. Okay, destination formatting. So it's gonna be look like this. Okay. Now it say over here A versus B. Okay, we have to change this to make sure we do understand what is A. So we can change A is actually control, right? This is 0 PPT versus B is 5 PPT. Okay. The second pair is A is control 0 PPT versus C is 10 PPT. This one is A 0 PPT and D is 20 PPT. And then the next one, A is control 0 PPT versus 40 PPT. Okay, the next one's B is 5 PPT, 5 PPT versus C is 10 PPT. Okay, the next one is B is 5 PPT and D is 20 PPT. And then B is 5 PPT. E is 40 PPT. And then C is 10, right? 10 PPT, and D is 20 PPT, and then C is 10 PPT, E is 40 PPT, and the last pairs will be D, which is 20 PPT, okay, versus E is 40 PPT. Now, we have this, so you know which one's pairing with which one. Look at this one. So 0 is the control. If you pair with 5, it's actually telling you the result is insignificant. It means that between control and 5 ppt, there is no difference. It means that the 5 ppt did not kill the seed. Okay? The same thing with control and 10. Okay, so 10 ppt did not kill the seed. However, if you see control versus 20 ppt, then you see here the p-value is lower than 0.05. So this is significant. So it means that this one is different. Okay, so control and 20 are different. So 20 ppt actually reduce the seed germination. And look at control N40. So there is also different. You can make it bold, okay, to make sure that these are different. Okay, and then look at 5 and 20. It is also different, okay, between 5, the 5 ppt treatment and 20 ppt treatment, there is different. 5 did not kill the seed. 20 is actually decrease the seed germination. 5 and 40, it is also different, so make it bold. Okay, and then 10, 20, no different, but 10 and 40, it is different. Okay, and then 20 with 40, it is also different. Okay, so now you see from these two key tests, you know which one is actually different. Okay, from the Anova, you only see that, it's only tell you there is difference between the treatment. Okay, and two key tests, okay, make it sure that the difference is actually 0 to 20, 0, 40, 5, 20, 5, 40, 10, 40, and 20, 40 PPT. So these are the one difference. So these treatments are different. Okay, so this is the conclusion that we have. Okay, the difference is between control and 20 and etc. If you see this number. Now, we can also, okay, do the regressions. So to know the correlation between these different treatment, how strong is the correlation? Okay, in order to do that, again, we click data and then click data analysis and then look for regressions down here. So it's called the regressions. Okay, and then click OK. Okay, now in order to put the input, you have to change your data a little bit. You're gonna put all the x-axis over here, which is the treatment from 0 to 40 with 3 replication each. And the other column over here is actually the y-axis, which is the result of this treatment, how many seed germinate, okay? This is also have 3 replication. Okay, so the input Y range is going to be the result, which is this one over here, number of seed germinate. And then the input for X range is going to be the variable over here, okay, which is the independent variable, which is the difference concentrations of salt, okay, from 0 to 40. Okay, and then we click that our confidence level is 95%. Okay, and then we're gonna put this in output range. Okay, and then you choose where you're gonna put this. I'm gonna put over here, down here, so we can see the results over here. Okay, and then click OK. Now you see the results here. Okay, so this is the regressions or correlations line. And then you see that the formula, okay, will be y equal to minus 0.24x plus 10.58. So you can type this formula, y equal minus 0.24, okay, x plus 10 0.58. So this is the regression lines gonna be. And then the regression coefficient, which is the R square, will be this one. Okay, the R square will be 0.92. Okay, so this means that this correlation is very strong. So the higher the number, the strongest the correlation is gonna be. Okay, if the R to 1, for example, is a perfect correlation. Okay, so this is 0.92, which is very strong correlation between the salt concentrations and the seed germination. Okay, now the next things you can do is to make the graph. Okay, to make the graph, then you have to create another data for his. This data is actually taken from this average. Okay, like for example, 0 or control, the average seed germinate is 9.67. 5 ppt is 9.33. Okay, 10 ppt is 8.33. The 20 ppt is 7.33, and 40 ppt is 0. So you actually copy this data and make a new data over here, which is the left columns gonna be the treatment, yeah, different soil concentration, control 240, and this right column will be the average that coming from that data. Now we're gonna highlight this, okay, and then click insert. Okay, you're gonna insert the table and choose the chart over here. Choose the scatter chart. Okay, choose the scatter chart. Okay, you see it over here. I'm gonna move it a little bit on the right side. Okay, then we can change this chart into the bar chart over here to see the nice comparisons. Okay, so choose column, then choose this one, the left one, and then click OK. Now you see the chart now is in the bar chart, which is really easy to compare between different concentration. You can type the title of this chart. Let's say this chart title is Effects of Salinization, okay, on seed germination. Okay. Now you can also put the add the axis title. Okay, so click the add chart elements over here, and then click axis title, and then choose the horizontal axis, okay, which is x-axis. Okay, so x-axis over here, you change the name. Okay, let's say x-axis is actually salt. Okay, salt concentration. Okay, which is in ppt, part per thousand. Okay, and then now you can add the x-axis, the axis title for y-axis, okay, which is the vertical axis over here. Okay, again, type your title for that axis. So the y-axis is actually the result, okay, the number of seed. Okay, the thing is number of germinating seed. Okay, so how many seed germinate? Okay, if you see over here, from here, okay, from this table, from this chart, you see that on the 0 or control, about 9.7 seeds, okay, are growing. 5 ppt, 8 point or 9.3, okay, and then this is 8.3, 7.3 is going down actually, and then in the 4 PPT, there was no seed germinates. So this is the chart for comparisons. Now, usually if you use this chart for journal article, for example, if you wanted to send it to journal article, they usually don't have a color in the journal, so you can change this color. Over here, okay, you can click this fill, okay, and then click field with color. So because we don't need color, we can use pattern. So pattern fill, okay, we can choose, let's say for control, we're gonna use this pattern, okay, and then use black color because, okay, use black color, okay, and then the second one, again, use black color with pattern. Let's say you're gonna use this pattern, and then the next one, the 10 PPT, you can choose black color and then patterns. Let's say use this, and the last one over here, the 20 PPT, use black color with patterns. Let's say this pattern. So you see the different patterns over here with black and white color. 40, there is no result, it's all 0. Now you can also put the line over here, the regression line. Okay, so just click this and then go back to the add chart element and then choose the trend, okay, the trend line. Okay, and then choose the linear trend line. Okay, and again, if you're gonna use for journal, we have to change this line into black color. Okay, and then solid line. This okay over here. Okay, we're gonna use solid dash. Okay, so you see this regression line over here, and also we can put our regressions formula here into this table. Okay, so we can insert shape and then this text box. We're gonna type it here. Okay, so y equal minus 0.24 plus 10.58 with the r square equal 0.92. Okay, so now you see the very nice graph over here. So everybody that know about statistics will know what is actually the correlation between this treatment, okay, between the different soil concentration and the seed germination. And then from this R square, and then from this, the formula, they know this is going to be negative correlations. Okay, so the number of seed germinates going to be decrease when we increase the salt concentration. And the correlations or the strong correlation will show you over here is 0.92. It's very strong effects of salt concentrations with the seed germination. Okay, so we can X this, and then you can save this, okay, save as in your file and your document, okay? So you're gonna have this data with you and you can use it. You can actually copy and paste this one into your journal articles if you want to write a journal with this experiment. So I hope this helps you how to do the data analysis, including also how to make a graphic using this Excel program, and also for the Tukey test using this website. Okay. I think we're gonna stop here. I'll see you again with the next topic. Thank you.